Yeah, somebody slapped my wrist. Okay, let's start. Green Book, NRCA.
Blue book.
Blue book.
I mean, Green Book, Blue Book, NRCA. You see, I started them already, you know. Okay, let me rewind
Yes,
the hard
no
drive.
problem.
Yeah.
It's all
Okay.
good. You have lots of credits with us, Mike. No problem.
In the Green Book, you guys saw, good evening, everybody. In the Green Book, you guys saw there were 5 different sets of roof systems, and each one had a table of contents. So you had 5 different tables of contents, one for each roof system, and then one for the whole book at the beginning. So in this blue book, you only have one table of contents for the entire book. That's going to be on page 7.
Yep, I saw that and I was like, no,
Okay.
why aren't these books set up the same way?
They're not, because these are NRCAs, and actually they used to be. Like I said, they changed their tune. Here, what they've done is they've replaced, not replaced, they actually sectioned different types of roof systems. Like the Blue Book is going to talk about flat roofs, membrane roofs, low slope roofs, any way we want to call it. But then it's one set of one set of table of contents only for the entire, which is in page 7. And this one talks a little bit about the introduction. Then chapter 1 is usually the roof assembly configurations. 2 talks about roof decks, which will be your roof deck, your air vapor retarder, your insulation, the way you build the roof, like you do the other ones. Then you have the membranes, the different types of membranes, attachment of the membranes, surfacings. Okay, Blue Book, guys. NRCA Blue Book. Accessories, re-roofing, like it's usually in all the other NRCA, usually the re-roofing is at the end. And then details and some appendices. This is what we're going to do. That's how the book is divided. So what we're going to be looking at is, again, now, typically, I would say, although there's information in the other books, this will be out of the set of a set of NRCA books, it will be the first book, the book that has a lot of the information that is general information. Not all of it, because you'll see the repetition on this. But take a look at the introduction, and on page 11, but we're going to be looking at page 12. That'll be, and then again, what we're going to do is go through what I have highlighted here as test questions.
Okay.
Okay, so if you look at page 12, look what it says, membrane roof systems. And there's a difference between a roof assembly and a roof system. And basically, the assembly of interacting roof components, including the roof deck, air vapor retarder, present, insulation, membrane, and so on. Now, look at the roof system. And the difference between the two is the deck. The roof assembly includes the roof deck. A roof system is what goes over a deck, on top of a deck, but does not include the deck.
Okay.
That's how, the way that, and then NRCA, if you look at on page 13, low slope roof systems and steep slope roof systems. There, in the low, basically NRCA talks about low slope roof systems between any type of system installed on slopes at or less than 3 in 12. So 3 in 12 is what the dividing slope for low slope and steep slope. And then it's going to be talking about how to use this manual. But if you want to know the type of roof membrane roof systems that we're going to be talking about in this book, take a look at page 14, chapter 5. What it says, chapter 5. And here it's going to tell you the type of roof systems that will be this book will be addressing. Look at the fourth line. Roof membrane types addressed include built-up, polymer modified bitumen, single ply, and liquid applied roof systems. So these are the roof systems this book is going to talk about. Now, like all the NRCA books, the first chapter talks about configurations, the different types of roof assembly configurations, because you talk about the deck and everything else like that in here. There hasn't been a test question on this part. You're going to see that the book is thick, but you're going to see how thin we get the book once we go through it, because half of the book is details at the end. So what we're going to go to page 81, and that's where we start. Page 81. Page 81 talks about roof decks. And in roof decks, page 81, look at the following types. Look at the first column there. Following types of roof decks addressed in the manual: cementitious wood fiber panels, lightweight insulating concrete, steel, structural concrete cast in place, the different types of structural concrete, wood panels, wood planks, and wood boards. So these are the type of decks that this book will talk about. Now we're going to have some guidelines applicable to all roof deck types. And look at page 82. Talks about structural support. Structural support talks about a roof deck transfers dead and life loads. Look at the third line in that paragraph. Life loads include environmental loads such as wind, snow, rain, and ice, and other non-stationary loads such as workers and mobile installation equipment.
This is on 82, right?
For life loads.
82.
Yeah, on page 82. Okay. Then on page 83 talks about roof expansion joints. These are going to be expansion joints usually on those low roofs, on flat roofs. And this is also standard with NRCAs. Take a look at page 83 on that big paragraph on the top, about 3, 4, 5, 6, about the seventh line into that paragraph in the top. For most low slope membrane systems, expansion joints should be detailed and constructed to a normal height of 8 inches above the finished roof surface. And you're going to see that NRCA, the standard for NRCA is 8 inches height, and flashing, the curves, things like that will be 8 inches above the roof surface. Then you go to the next column and you talk about roof area dividers. And now roof area dividers, you're going to see that there's different things that roof area dividers do, but they're kind of spread out. If you look at the first, right on the roof area divider, the third line, starting there. Roof area dividers are sometimes used to, number one, separate adjacent roof areas where the thickness of the insulation is not similar. Then continuing on, roof area dividers are also sometimes used to, number two, define adjacent work areas. And they give you an example. Then on the following paragraph below that, roof area dividers may be installed, number three, to divide large roof areas into smaller sections to minimize buildup of thermal stress in adherent membrane roof system. So these are three different things that you use roof area dividers for. Now, on one more line below that, talks about depending on climatic conditions, area dividers for built-up roof, polymer modified bitumen, and adhered single-ply membrane systems are generally required at 150 to 200 foot intervals. 150 to 200 foot intervals. And then you're gonna see again the 8 inches. Look at the following paragraph below that. In roof area dividers, if roof area dividers are used, they should be flashed to a minimum height of 8 inches above the roof surface, located at high points in the roof with drainage away from parallel to the divider, of course. Then slope and drainage, right underneath. And you see that, usually this book, particular book, talks about the International Building Code 2021 edition, indicates the design minimum slope. 1/4 is required for membrane roof systems, except one, coal tar built-up roof, where the design minimum slope is 1/8 in 12 is permitted. The next page, and again, these are general guidelines. And you see this thing, you remember the 8 inches. This next, what we're going to be looking at, you'll also remember it if it comes in a test. Looks as nrca recommends roof systems be sloped to provide positive drainage for a finished roof system. Then 3 more paragraphs below that, the criterion for judging proper slope for positive drainage is that there'll be no ponding water on the roof 48 hours after a rain event during conditions conducive to drying. So the question comes for positive drainage 48 hours. If you remember that, you don't even have to look for it in the book. That's positive drainage according to nrca. And then we're going to start looking at the different types of decks. Look at page 86. We're going to go to a first deck, which is cementitious or wood fiber panels. What are they? Look at the second paragraph. Cementitious wood fiber panels used as roof deck components, composed of treated wood fibers bonded together with cement and or other binders, compressed and molded into panels. That is a cementitious wood fiber panel. And then you talk about different things now, going into attachment of roof system components on the next page. But we're going to be looking at the second column, on the second column of the page, the second paragraph. NRCA does not recommend directly adhering a base sheet, rigid board insulation, or roof membrane to cementitious wood fiber panels without installing a mechanically fastened base sheet or other separator layer. Then 2 more paragraphs below that. We are on the Blue Book, NRCA Blue Book, page 87. Then 2 more paragraphs. Care should be taken so cementitious wood fiber panels do not contact open flames, such as an installation of polymer modified bitumen sheet product. The same thing. It's pretty much the same thing because they're flammable. That's what I got. Continuing on, still on this deck, some cementitious wood fiber panels, on page 88, look at the very top. It's kind of a repetition thing, but this is where the questions have come different ways. NRCA does not recommend the use of seam fastened mechanically attached single ply membranes over cementitious wood fiber panel roof decks because of the potential for the fastener holes to reduce a cementitious wood fiber panel roof deck's structural integrity and alignment. Two more paragraphs below that. For liquid applied membrane roof systems, a base sheet should be mechanically fastened to cementitious wood fiber panels before installing the liquid applied roof membrane.
So Mike, the one that it says does not recommend, meaning you have to do a hot mop ply. Is that what it is? Like without the fence.
Basically, what they want to do when they say the NRCA doesn't recommend it because they're hot, right? So you need to have a base sheet before you apply anything like that. So there's
So
gotta be
you gotta have some type of base sheet.
exactly. So there's a separator between the cementitious wood fiber, fiber panel. I think
Oh,
I've
no,
seen
I was talking about the last one before.
the liquid
Yeah,
applied.
the wood fiber does not recommend fasteners, mechanical fasteners.
Because basically,
Meaning you cannot
you
put
say
holes on the concrete.
yeah, look at the procedure is intended to separate a liquid applied membrane from direct contact with the deck surface and to protect the integrity of the deck when the roof system is removed. And then you talk about different additional information on all that on the configuration. But usually that's what it is. They want a separator sheet. I don't know if you guys have seen a cementitious wood fiber panel, but there used to be years ago. There's some warehouses in Miami down on the northwest area. I would say between 36th Street and 58th Street, something like that, between
Wow.
June and 27th Avenue, somewhere that area there, the old warehouse areas. And there used to be some panels, and I think those are the ones that the roof was there, and they had like little mini joists that would attach to, that would be holding the panel. They would get together with the panel. But what happened with those things with time, and this happened to me years ago, we were looking into one of the roofs, you step, and all of a sudden your foot goes right through because the panel is completely rotten. It was a very dangerous situation.
All right, thank you.
So now we'll go to a lightweight insulating concrete. Now, lightweight insulating concrete, there are two types. If you look at the bullet points. Aggregate insulating concrete, which has aggregate in it, and usually what they're looking for, what they have looked for, is the compressive strength of each one. The aggregate insulating concrete, look at the next, in the next column, at the end of the first bullet point. They say lightweight aggregate. Lightweight aggregate insulating concrete should attain compressive strength between 125 and 400 pounds per square inch. That is a lightweight aggregate. Now you're going to see the cellular, which is,
But it's
basically
125 to 400 per square inch,
Yeah.
right.
not cubic foot.
Actually, it should say cubic foot, right? For
Well-
compressive strength. Yeah.
It should, but it says square inch.
Okay, because if you look on top, talk about the oven dry density between the it's 20, 40 pounds per cubic foot. The density.
Right.
Then
You want to pass the test, right?
yeah.
Don't argue. Don't argue.
No,
I'm not
that's true.
arguing.
If it
No,
says
no, I'm
but
saying-
it's
I'm
true.
saying.
What happens in here? If it says that, usually
If it
you're gonna
says
see
here-
you're gonna have the whole sentence, and all you need to do is plug in the numbers.
Oh, okay.
So when you do that, you plug in the numbers. That's it. They give you the different set of numbers. Like for example, they talk about that. They give you 125 to 400, something like that. They give you according to which one, because the other is cellular. Look at the bottom, 160 to 350,
Right.
and they give you both. In other words, you got to make sure that which of the two.
Yes.
Yeah, but that's true.
I
You
got
need
it.
to
Yeah.
answer the book.
Yes. Answer whatever it's in the book. Exactly.
Again, it's the same thing. You're gonna see the same thing. The weight of concrete, regular concrete, 150 pounds per cubic foot. I think he has it for square feet. We're gonna look at it in a couple of minutes. But look at lightweight insulating concrete on the very bottom. Should not be confused with lightweight structural concrete. And then look at the fourth line, typically having a density of 90 to 120 pounds per cubic foot. That's the way it should be. Now the design, the next page, 89. In design, go 1, 2, the third paragraph. NRCA recommends lightweight insulating concrete roof decks be a minimum of 2 inches thick, not including the thickness of any foam board or other underlaying substrate. 2 inches thick for the lightweight concrete above the insulation. Then venting and drying. On venting and drying, the
Sorry,
second
Professor,
paragraph.
what book are we in?
We are in the
Book,
blue,
membrane.
the NRCA Blue Book.
Thank you so much.
All right, and we're on page 89. And then on venting and drying, look at the second paragraph. To promote adequate drying, lightweight insulating concrete roof decks should generally be vented from the underside. And then it's basically the same information, but look at the next paragraph below that one, the last one on the page. Lightweight aggregate insulating concrete poured on metal form deck should have underside venting provided through slotted holes in the metal material. If you've ever done one of those, you know the big mess that this thing leaves in the floor, in the freshly poured floor of that
I
big
bet.
warehouse.
For concrete, yeah, that's a mess.
It is. A lot of visqueen all over the place before you do anything.
Absolutely.
Then
Maybe
we're gonna
3
go-
layers.
Yes. Then we're going to go to page 92. And this information that we're going to be looking at now in steel, it is in the orange book and the red book, exactly verbatim what you see here. So you're going to have this same information for steel decks in 3 different books. The red book, you have it twice. Then in steel deck, what we need to know is the 4 types of decks. Narrow rib deck. If you look at on the bold, it talks about narrow. I mean the narrow rib deck type A deck panel with a rib width opening of 1 inch maximum. Then the intermediate is a steel deck panel with a rib width opening of 1 inch to 1 3/4. The wide rib steel deck panel with a rib width opening of 1 3/4 to 2 5/8. Now comes usually the test question that I've seen is between the wide rib and the deep rib, which we're going to be looking at now. Because the deep rib steel deck panel with a rib width of 1 1/2 to 2 3/4 and a rib depth of 3 inches. That's the difference. The deep rib has a depth in the rib. Then on page 93, talks about materials and then design on the design section, but on the second column, the 3rd paragraph, or the second full paragraph there, the 3-liner. Most existing steel deck panels are fabricated from steel with a minimum yield strength of 33 KSI or grade 33 steel. And then 94, page 94, first full paragraph. NRCA recommends steel roof decks be 22 gauge or heavier and have a minimum G90 galvanized coating complying with ASTM A653. And you know, it's a lot of ASTM designations here, and usually the ASTM designation so and so and so come to the NRCAs. Then you have structural supports. And structural supports, look at the end of the 3rd paragraph on structural supports, the last statement. As a guideline for proper alignment of steel deck panels, horizontal variance in the alignment of the panels shall not exceed 1/4 of an inch for any 100 feet of roof length. Then end laps, and it's still the steel deck panel. Deck panel end laps should not be less than 2 inches, centered in structural supports. Then all side laps should be mechanically fastened. Side laps fasten spacing should not exceed 3 feet. Then we're gonna go to page 97, still on deck attachment, and we're gonna be looking at deck attachment. And the section of deck attachment, but it's gonna be on page 97. And look at right above the bullet points that we have on the first column, right above it. For steel roof decks with spans greater than 5 feet. Side laps. You're gonna see side laps, and then you're gonna see perimeter edges on the same information. Side laps shall be fastened at 36 inches on center maximum using one of the following methods. And what I would do, I just highlight the bullet point itself instead of highlighting the whole thing, the different types of method that could be done on steel deck panels for side laps. Then on the next column, right above the 3 bullet points, for steel roof decks with spans greater than 5 feet, the same perimeter edges. One is side laps, the other is perimeter edge. The same between span support should be fastened 36 inches using one of the following methods. Roof openings, attachment of roof system components. Then we go all the way to page 100, structural concrete. That's another type of deck that this book deals with. In structural concrete, take a look at the end of the first column. There are 2 general types of structural concrete used in roof decks: normal weight structural concrete and lightweight structural concrete. And then we're going to see what each one of the 2 is. On the bullet points on the second column, at the end of the first paragraph of the first bullet point, the density.
I'm sorry, I got lost.
Uh,
Where are we? On
we
normal
are on
weight?
page 100,
Yes.
normal weight structural concrete, second column, first bullet point.
Oh, I see it now. Okay.
The density of reinforced normal weight structural concrete, generally 150 pounds per cubic foot. And then you have the same thing that we saw a little while ago, lightweight structural concrete. Towards the end of that first paragraph, lightweight structural concrete have densities ranging from 95 to 120 pounds per square foot. This about 80% of the density of normal weight structural concrete. See, you have, again, there's a few typos like that. We know what it is, but we answer the book.
Right.
Then we're going to talk about the 3 types of concrete installation of structural concrete roof decks. On page 101, towards the end of the page, it says there are 3 general installation types of structural concrete roof decks: cast in place, post tension, and precast prestressed. And then you have the cast in place concrete. The next page, you have the post tensioned and the precast prestressed concrete. And you know the difference between the 2. The post tension usually is the one you usually have on multi-floors buildings, you know, that you post tension the slab after it's poured. So you pour the concrete, let it start setting a little bit, and you start pulling cables. And the other, with the precast pre-stressed, you do it in a yard. You have the cables completely stressed, you completely pull the concrete, and once the concrete sets, you let the cables go, and all of a sudden that thing goes and creates a camber. That's what that is. Those are the precast pre-stressed. Attachment to existing components, nothing in there. Okay, now starting on page 105 talks about attachment of roof system components to structural concrete. But on 106 is where the question came. The section is attachment of the components. It says built up and polymer modified bitumen membranes may be adhered directly to cast in place structural concrete roof decks. Built up and polymer modified bitumen membranes should not be solidly adhered directly to precast concrete panel roof decks for obvious reason. You're going to move. Now we talk about wood panels. Talk about wood panels, you're talking about plywood and OSB. Those are the wood panels. Sheet of plywood or a sheet of OSB. Now, you saw on the green bill in the green book, when you looked at the green book on the different types of roof decks, each one talk about the wood panels, right? The plywood.
Mhm.
But then in the three roof systems that were light, like asphalt shingles, the metal shingles, and the wood shingles and shakes, if you were using that type of deck, you use 1/2 inch plywood for 16-inch spacing and 5/8 plywood for 24-inch spacing on the joist underneath on the
Right.
truss. And if you use concrete and clay tile or you use slate, you went to 5/8 for 16 and 24. And 3/4 for 24-inch. So here, because these roofs are light, you're going to look at your page 107, look at the second paragraph, and this is, well, actually, yeah, that's what it is. When plywood is used as a roof deck material, nrca recommends the use of minimum 4-ply 15/32, which is 1/2 inch plywood for 16-inch joist or rafter spacing. And 4-ply nominal 5/8 of an inch thick plywood for 24-inch joist rafter spacing. The same thing, 2 more paragraphs below in OSB.
Junk. It's junk.
Yeah,
Junk is not the word for that.
yeah. They should-
OSB, I would never
Oh.
use it on the roof deck. It's junk.
Nope.
Of course
Nope.
it is.
You're asking
That
for
thing
problems.
rots with the time and it's very loose. I don't think it has the same strength to begin with.
Vertically, it's fine. Horizontally, it's no good.
Exactly. I agree 100%.
Ugh.
Now, things that you've also seen on the Green Book. Look at the last sentence on the plywood and OSB sheeting panels should be on the same column. The last sentence on that column. Be installed with the proper spacing gap to allow for expansion. Generally, unless a panel manufacturer recommends otherwise, spacing between edges recommended to be 1/8 of an inch.
Repeat that.
Okay, you start in the very bottom. It's the same thing that you seen in the
What
that
page?
you had in the Green Book. Plywood and OSB sheeting panels should be installed with proper spacing and gapping to allow for expansion. Then generally, unless panel manufacturers recommends otherwise, spacing between panel edges recommended to be 1/8 of an inch.
For it to expand.
You've seen that throughout. It's something that gets repeated. Then we're gonna go to page, Jones opening attachment of roof system components into that.
What page?
Page 108. Page 108, attachment of roof system components.
Got it.
In the attachment of roof system components, look at the second, which is in the second column, the second paragraph. For wood panel roof decks not covered with rigid board insulation, a base sheet should be mechanically fastened over the wood deck, preferably with annular threaded ring shank barbed nails to serve as a base ply for the membrane roof system. Then on the next page 109, second paragraph. nrca does not recommend the torch application of polymer modified bitumen membrane sheets directly to combustible substrates. That be something?
I wonder why.
Yeah.
Yeah, I'm still wondering.
Yeah.
Yeah.
You have a nice
Yes.
bonfire.
Barbecue.
Jesus. I mean, I can't believe they have to actually write that.
Isn't it amazing?
Well, actually, you see this, and the thing with this book, remember one thing though, the NRCA books are in some states that do not have the codes that we do have. They're a lot more lax. This serves as the standards to do roofing, and they want to make sure that they cover everything because you never know who you have out there.
This is our,
Believe
the
me,
Bible
you
in
guys
other
know
states.
exactly. And you guys know sometimes what we can find out there in, working. So.
Yeah, you're right. You're
so
right.
it needs to be said.
Absolutely.
Some crew chiefs are not good teachers.
The other thing is it's in popular language. It's not very technical. I mean, anybody can grab these books and read and have a good idea of what it's talking about. It's
Yeah.
not like using crazy words, technical and blah blah blah.
Oh, no,
So
that's, they're pretty simple. Well, it's simpler than, RC is simpler in the way they talk, roofing, construction, estimate. But this is pretty much, in other words, oh my God, look what it says over here, but it tells you. And then again, this serves as the standards.
Right.
So look at now, chapter 3, vapor retarders.
Oh,
Look at the definition of air retarder and the definition of vapor retarder. Air retarder, material system in building construction designed and installed to reduce air leakage into or through the opaque wall.
Boom.
Yeah. And then vapor retarder, a material system that significantly impedes the transmission of water vapor on the specified condition. Fundamental air retarders. Air design, vapor retarders. All I have, I believe, only thing about sandwich type. Let me see if that's what it is. No, actually, deck type. All the way on page 127, 127. You'll see the different details for the air retarders, the vapor retarders, and all that. 127 talks about selecting vapor retarder materials. And then underneath that, roof deck type, possible puncture damage. And then starts in northern climates, adhere roof system installed over solid continuous surfaces such as cementitious roof fiber panels, lightweight insulating concrete poured or precast gypsum panels, structural concrete and wood plank structural wood. Vapor retarder is best placed. Talks about those. Where is a vapor retarder placed? It's best placed at a level directly above the roof deck to minimize the potential for puncturing the vapor retarder. So this is on the northern climate. Now, the next paragraph below that. The placement of vapor retarder directly over steel roof decks has proven to be generally unsuitable because a flexible vapor retarder sheet could be vulnerable to puncture damage from boot and equipment traffic that takes place between the ribs and the panel. Therefore, the vapor retarder should not be placed directly over the steel roof deck. The vapor retarder should not. Then look at what it says, sandwich type construction. It says when vapor retarders are to be installed over steel roof decks, NRCA recommends sandwich type construction be employed. And that statement is all over the place in the other books too. Every time they talk about that, mainly on the red and the orange. And now we're going to talk about insulation. Any question that you have in the test about insulation, Blue Book, Chapter 4. Even though RCE sometimes mention it, you have a little bit of mentioning, but this is where you have actually most of the information. In Chapter 4, Roofing Construction Estimate, NRCA Blue Book. So you have guidelines applicable to all insulation types. And what I would do there, it'll be just highlight the bullet points. We are, I'm sorry, I'm looking at,
129.
we are in the,
127?
what book? Hi, on page 129. Start
129,
there.
yeah.
What we are in the NRCA Blue Book, the
The
Blue Book for
guidelines.
NRCA. And basically roof
Rigid board?
insulation on the blue book.
But
NRCA
this
blue
is the rigid board installation.
Yeah, rigid board insulation, chapter 4, page 129. Guidelines applicable to all insulation types.
Highlight
Then-
bullets.
You come back?
Highlight the bullets is what you said, I thought.
Yeah, just highlight the bullet points.
Yeah, I
It can
got it.
reduce the energy required to heat. It can reduce potential condensation, all of that. Just highlight the bullet point. That way you could refer to that in case you need it. Because you start highlighting this whole thing.
Hi,
the
I'm
whole page
just,
is highlighted.
I'm
Yes,
sorry,
I
I'm
know.
just logging on. Which book are we using?
The blue book, NRCA blue book membrane, this one.
Okay, thanks.
All right. And we are on chapter 4, page 130. Then on page 130, desirable properties of roof insulation. Desirable properties of roof insulation. And you got again the bullet points. Compatibility, component compatibility, impact resistance, fire, moisture, all that good stuff. And then we go to the types. These are the types of insulation we're going to be talking about. This book is going to be talking about now this chapter. Cellular glass, expanded, extruded polystyrene, glass faced, fiber reinforced gypsum. The last one is tapered insulation. R values, about where it says R value. Thermal performance properties of rigid board insulation reported based on the product's thermal resistance value, commonly refers to it R value. The R value is the thermal resistance.
Thermal resistance.
Right. Then on the
See,
next column, thermal conductivity, which is K. Then thermal conductance, which is C. And then thermal transmittance, which is a U factor. And then they go on to, it goes on to explain each one. But there, if you look at that, on that column there, the two liner in the middle of the column, C factor and U factor are the mathematical inverse to R value, so it's K. Each one of those letters is inversely proportional to R. K equals 1 over R, C, U equals 1 over R, and the other way around. R equals 1 over whatever those are. So sometimes you get a test question that actually has the whole system, and they give you the R value for this piece, this, and they give you a set of R values. You add them up, and then what is a U factor on that? 1 divided by all of those. That's one, that's how.
I get it.
Yeah. Then on page 132, it goes to explain each one of the letters. Thermal conductivity K. The easiest way to see it is the second liner on the second paragraph. The thermal conductivity K value applies to 1 inch thickness of a specific material. Then the thermal conductance C, look at the last two liner on the page. Thermal conductance C factor applies to specific thickness of a specific material. On the next page, 133, about the middle of the page, first column, the thermal resistance R, again, the three liner. Thermal value applies to a specific thickness of a material or construction. Sometimes different, put together. This, they add all the R values of that particular construction type. Then the thermal transmittance on U factor, you'll see right on the top of the second column, the thermal transmitting U applies to the overall thermal performance of the system to find the U factor. And then you see a table, it has a U factor and you have the R value. According to the R value, you see the U factor. And actually on the 134, it talks about that. Thermal resistance calculation. If you leave page 134 on the second column. The thermal resistance calculations are accomplished by adding the R values of the individual components of a building assembly and then, if necessary, determining the assembly's overall coefficient, U. And if if you look at page 136, you're going to see a table there. The component of a system and the heating condition, the R value, and the cooling condition, R value. Then we got multi-layer insulation. Well, okay. So now that goes through all the insulations. Now we're going to see each typical insulation. Basically, most of the time, usually the question is the R value of such and such insulation. The R value is what? And this is what you're going to see now. Cellular glass. And you're going to see the standard also, which is important. On the cellular glass, look what it says, product standard.
Oh.
Which is on the second column.
Mr. Don't want to.
Huh?
139.
Or page 139. Starts cellular glass insulation. Then on the product standard, the US product standard for cellular glass roof insulation, ASCNC 552. These are standard specifications for cellular glass thermal insulation. And this is a catchy question. And ASCNC 1902, standard specifications for cellular glass insulation used in building and roof application. So the standard for building and roof application is a C1902, not the C552. And this is the type of questions they love to hit you with.
Yeah, it wasn't one of the practice exams,
Right.
practice quizzes.
Uh-huh.
And if I was gonna actually answer C552, but I read it well, I said no. C1902 is the correct answer.
One of the things, and I tell you that what you just did right now, Pedro, is usually what happens to all of us out there. You get antsy and you start reading and you find the answer. And if you don't read the question and read the whole answer, sometimes you won't.
We have the habit of, when finding the first answer in the book,
Right.
assuming that is the correct
That's it.
answer.
Exactly.
But they always try to trick, because
This is why they go for the second one.
exactly.
Or to fix them up.
Yeah.
That's what
They want, this is what they want from everybody.
course.
They want you to come back.
Of course they want you to come back. They hate it when you pass it the first time. When is it? Tomorrow?
His is
Saturday.
Saturday.
No, Saturday. Saturday, that's right. Saturday.
Yeah, his is Saturday.
Oh my
Mhm.
God. Well, I'll be saying a prayer for you.
Yep.
Okay, 140. R value, page 140.
Mm-hmm.
Cellular glass roof insulation has an R value of 3.44 per inch. Base tested at 75 degrees, 3.44 per inch. Then board sizes and thicknesses. This is something that came out in board sizes and thicknesses. The second paragraph there. Faced cellular glass roof insulation typically available in 2x4 foot board sizes. Faced cellular glass insulation. Then tapered cellular glass roof insulation typically available in blocks 18 by 24-inch boards, tapers of 1/8, 1/4, 1/2 of an inch per foot, tapered on the 24-inch side.
I've only seen cellular glass insulation once in my life, 40 years ago, on top of a building around a swimming pool.
I have never seen it, to tell you the truth.
It smells really bad.
It does?
Sulfuric, yes.
Oh, because I've seen the polyiso is the one everybody uses.
For using only once, 40 years ago, the smell is
40,
pretty bad
40,
then.
40
Yeah,
years.
40.
Wow.
It's because the smell is pretty bad. You still remember it.
Remember.
Had to be.
It won't absorb water. That's its chief. That's why it was on the swimming pool. It doesn't absorb water. It's closed. Really closed cell.
Wow. Yeah, I have never seen it. And then look at the next statement. The minimum thickness for tapered cellular glass insulation typically is 1.5 inches.
That's what it was. I had to break it out.
Yeah, I bet it was hard to break out too.
Um,
No?
it was dangerous. It was dangerous because you're chipping glass and you have to protect yourself.
Yeah, well, that's right. Now look at multi-layer insulation. In the usage guidelines, when it talks about multi-layer insulation, look at the second paragraph in multi-layer insulation. nrca recommends design and specify cellular glass insulation as multiple layers. All the joints of the insulation boards in a layer should be staggered and offset all the joints neighboring layers a minimum of 6 inches. This is exactly the same thing. It's a repetition. Then, still on cellular glass, look at the second column, the first bullet point, application and securement. Then, on first bullet point, talks about unnailable roof decks. nrca recommends a base sheet be mechanically fastened to the nailable roof deck substrate. Then the last, on the first bullet, on that bullet point, couple of lines below that, cellular glass insulation then can be adhered to the base sheet using hot bitumen or other compatible adhesive. Then steel roof decks. nrca recommends a base layer of rigid board insulation such as glass face gypboard, fiber reinforced gypboard, stone wool, or wood fiber board be mechanically fastened to steel roof decks. Below the two bullet points, that little paragraph, nrca does not recommend the mechanical attachment of cellular glass roof insulation. Yeah, start nailing that thing, see what happens.
Exactly.
Then in non-nailable roof decks, below that other bullet point. On non-nailable roof decks, nrca recommends cellular glass roof insulation board be applied using hot bitumen or manufacturer-approved adhesive over the properly prepared deck. See, same repetition. So this is cellular glass. Now we go to the next one, which is expanded polystyrene. And again, the product standard on page 141 on the second column. Product standard, US product standard for expanded polystyrene insulation, ASTM-C 578. On page 142, you have the R value. And then according to the type, the R values for expanded polystyrene insulation vary according to the type of classification that range from 3.1 to 4.3 per inch of thickness.
And it will absorb water eventually.
Yes, that one will. And then ASMC 578 provides for a minimum R value of 3.8 for a 1 inch thick product. And then underneath, you have the EPS, which is the expanded polystyrene, the classification, the strength, the density, the R value per thickness. Usually the R value is what they're looking for. And you're going to see, if you want to, you highlight it, multi-layer insulation, you see exactly the same repetition that you saw on cellular glass. Look at the top of the second paragraph. nrca recommends designers specify continuous expanding polystyrene insulation as multiple layers when multiple layer expanded polystyrene roof insulation is used.
Staggered and offset.
On the second column on the top.
Yeah, the staggered and offset again.
Yeah, the offset 6 inches. If you go through the whole paragraph, you're gonna see, they're gonna tell you stagger the, you know, the layers 6 inches. And it's a repetition of the insulation. Now, on compatibility on page 143, compatibility. Look at the next to the last paragraph there. Expanded polyester insulation can melt and be destroyed by hot asphalt. Expanded polyester insulation can also be damaged or destroyed because of chemical incompatibilities with coal tar pitch, cold process membrane applications, and certain solvents using adhesives and cleaning agents for single-ply membranes.
And don't kneel on
No,
it.
no, neither one of the two. You know, the extruded. Okay, even though the extruded is a little stronger. On page 144, look what it says, roof membrane application. Expanded polystyrene insulation can be damaged by solvents, solvent-based adhesives. Insulation is not compatible with hot asphalt heated up to more than 250 degrees Fahrenheit. So this is the expanded. Now we're gonna see extruded polystyrene.
Good stuff.
Okay, the extruded polystyrene, if you look at the product standard, it's the same, C578. So, because of both polystyrene insulation. And then, if you look at the next page, 146, you have the R value. Again, talks about the R values there. They range from 3.9 to 5 per inch. And then the following line below that. Generally, an R value of 5 per inch thickness is used for extruded polystyrene insulation on a roof system application.
I don't
Yeah.
see that. Can you tell me where that is?
Okay.
I'm sorry.
Look at the R value.
R value.
The R value.
Paragraph.
Okay, first
Well,
in the third line, it tells you,
146.
you know, it ranges from 3.9 to 5. And then if
Perfect,
you
found it.
continue reading down, you'll see the 5.
The
Basically,
5.0 per
that's
inch,
the,
right?
what, you know,
Perfect. Found
that's,
it. Thank you, guys.
then you'll see that the table, which is slight different than the EPS. And you see cover board, combustibility, compatibility. But again, if I don't have it highlighted, because it didn't come from this insulation. I have some stuff that is highlighted from other insulations. Like, for example, 148 talks about the extruded polystyrene insulation roof membrane application. 148, second paragraph. Fourth line, third line, extruded polystyrene insulation not compatible with asphalt heated more than 250 degrees. The same thing as the expanded.
Where they say the second paragraph, third
Yeah.
line?
There's no
Roof membrane application.
roof membrane application right on the first paragraph, the third line, second column.
Oh, second column.
The second column, roof membrane application. Yeah, that's where it is.
Do you see the 250 Fahrenheit?
Yeah.
250
It's
degrees.
that sentence
Same
right
thing.
there.
Yeah. What the heck is this? It's just all of a sudden I get a sign here, confirm the language you're speaking. Maybe I'm speaking Chinese or something. I don't know. Farsi, I don't know. Glass-faced insulation, which is the next one, 149. And then look at the recognized properties of glass face, because it came out, it was a test question on glass face insulation properties. Adhesive compatibility, component compatibility, fire resistance, moisture, stable R, all of that. Then Product standard again, C1177. Typically, when you start looking at the product standard, if you only have one and you see that it repeats, you know, that's the product standard. But if there's two product standards, make sure you read what the standard is about. That's what's important. Then on the second page here, the R value gives you a table according to the thickness. I will just highlight the table. This is for glass face. Now we got fiber reinforced gypsum. Fiber reinforced gypsum. Again, on fiber reinforced gypsum, highlight the bullet points, the recognized properties, which are pretty much the same. And then you're gonna see the ASTM C1278 on the product standard on the second column. And then according to the thickness, the R value on the table. Stone wool starts on page 153. On stone wool, again, the properties of stone wool. So sometimes you have certain properties that the other one does not. Then the product standard, you got two. ASTM C726. Standard specification for mineral fiber roof insulation boards. Sometimes ASTM C612, standard specification for mineral fiber block and board thermal insulation.
God bless.
Okay, thank you. And then here it talks about the 726 and gives you a table based on the R value based on the 726, the ASTM 726. And here you can see combustibility on the second column, right in the middle of the column. Stone wool roof insulation is non-combustible. It can be exposed directly to hot bitumen, torch flame, or high temperature, such as the ones produced by heat welders. Then you have perlite on the next page. And in perlite, you have 7 properties, the bullet points. The product standard, C728. Then on the next page, you have the thickness and according to the perlite and 3 types of perlite. And here, there were some test questions that were kind of, kind of weird, but that was a test question. Look underneath in board size and thickness. And then you look at very type of manufacturer. Type 1 perlite available as 8 pounds per cubic foot nominal density. Then a few more lines, it's about 3 more lines below that. Type 2 perlite available as 10 pounds per cubic foot and 12 pounds nominal density, flat stock, 2x4, so and so. 2 more lines below that, type 3, available in 14.5 pounds per cubic foot nominal density. So here, there's been a question about which type of perlite and what would be
The thickness.
Yeah.
The density, right?
the density on each one. Then the same thing in combustibility, which is in the next column, where it says combustibility, perlite board insulation generally is considered to be non-combustible. Then you have polyisocyanurate. And there, again, the recognized properties. I think the question that I have seen with the properties, I think the polyiso is one of the ones that I've seen repeated in tests. The following recognized properties of polyisoanurate insulation make it effective insulation material. Then on page 158, you have the product standard, which is ASTM 1280 C1289. Then the R value starts on page 158 and it goes all kinds of stuff until you get to page 159, second column.
Jeez.
Looking at the LTTR and all kinds of stuff there. But then on page 159, second column, says NRCA recommends designers consider specifying polyisocyanurate insulation based on in-service R value of 5 per inch.
Aged.
See it on the second column,
Yeah,
Oh,
first
59.
full paragraph of the page.
that's the aged R value.
Huh?
That's the aged R value.
Yeah, the
It's usually a 6 or 6.2.
no. But if it comes in a test,
That's it.
answer 5. Please do that. Now take a look at the next page and you're gonna see the thickness. Then you have the LTTR, but you have the NRCA recommended design R value on that table.
This and RCA books are just like when I say like the code book is like the minimum, right? For example, as Andy were saying, normally 6.2, but here it says 5.0. So if you go
Right.
more, yes, but it's like this is the minimum requirement,
It
right?
won't exactly, it won't be less than
Yeah.
that.
Perfect.
And then you'll see according to the thickness of the board. You talk about a 2-inch board, he's got a 10. Because it comes in different thicknesses, different. I never seen it so thick, that's 40, 4 inches thick. I never seen that thing that thick, but it comes.
For an ISO board?
Actually, I did see it.
I was
And
gonna
we
say, I've
use
seen
it as
ISO board
insulation.
that thick.
Huh?
I've seen ISO board that thick.
No, I did. No, I saw it, and I think they got it, and we used it as a cover so stuff wouldn't fall into some areas. And
It wasn't for an
the
application.
metro mover you couldn't have a little rock fall
What page are we on?
into the lines, and then
One
we had to
sixty.
cover it up with all kinds of stuff.
Which billionaire were you working for?
Actually, I tell you what, that job was a few years back. I don't know if you remember where the old Goodwill Industries building used to be. That then it became the I think is what do you call it? I don't know. It's a building right next to the People Mover there. It used to be coming up the ramp from downtown Miami. It used to be the old, that building had reinforcing steel rebar. When we started demoing the building, that was square rebars, 1-inch square reinforcing steel. Instead of being round, was a square.
Wow.
And we saw all kinds of writings there in pencil back in the 30s and the 40s or something like that. I can't remember it right now. But when we had to demo the building, we couldn't, the city would not allow us to drop one little rock on top of the rails. So we had to cover that whole thing with insulation, huge boards and about 6 inches thick. But it wasn't, I think it was, all covered up before we did the demo.
Were the rails important? Were they aesthetically pleasing or something?
No, actually, the whole idea is
They
that
don't want
you
it
have to cover it because of the train. To
Yeah.
go by so close to the building,
Uh-huh.
you know, you know, it was right there. Actually, the whole idea originally was to implode the building. We even
Right.
brought in people to implode the building, but it was so close to the rails that the city decided, no way, Jose, because you might damage the foundations of the rail, you know, the rail
Yeah,
system.
people-
And they said no.
Oh,
So we ended up having to, you know, to do it, you know, the old-fashioned way. That was
those,
amazing
I
to
thought
do.
you meant railing.
Huh?
I thought you meant railing, not
No,
rail.
the rails, the train
Yeah,
On
rails,
on top of the people
the
move.
train
Endo.
rails, they're right there. FedEx building,
Yeah.
FedEx building downtown. That's what that used to be the old, you know, long time ago. That was you know, the original building, and you know, that was a feast.
Next
That was
time.
a feat, not a feast. Something to that was something. Okay, now we'll go to the next insulation, which is wood fiberboard, which is in
Are we skipping high density
yeah,
polyiso?
skipping, yes, polyiso because nothing happened there.
So page 163.
Oh, okay.
And then we go to 163 wood fiber board, but the question came from 164. And there, you see that is repeated again, a lot of this. The R value, 278 per inch on page 164. In multi-layer insulation, second paragraph, the same thing we've seen in the other ones. When multi-layer, look at the third line, the fourth line, in the, you know, when the second paragraph in multi-layer insulation section. When multi-layer wood fiber board roof insulation is used, all the joints of the insulation board in a layer should be staggered and offset from the other joints, 6 inches. Cement board, will be the next one. Page at the end of 165. The 160,
Is that a name for tectum?
come back?
Cement board, is that the same as tectum?
I think so. I believe so.
Or maybe it's cementitious wood fiber is tectum.
Right,
Yeah, no, I was gonna say
Google it.
no,
yeah.
because tectum has fibers in it.
Here, it tells you what it is.
We Google it.
Portland cement, pozzolans, water, and aggregates. Non-woven polyester fabric reinforcement applied to machine direction, and you know.
Where are you reading that?
Well, I'm reading that.
Google.
Talks about, you know, actually it's interesting to see, you know, like if you have the time and want to play, you start reading each one of the boards, it tells you, it explains what each one of the boards says. Here is at the end of 165.
Are we jumping to composite board?
A little bit about what it is composed of and things like that. But I didn't say anything because it usually doesn't tell me that that's a test question. So,
Of
but
course.
each board, each one of these things, you start, like if you get to read it, it is very informative and it does help understand it a lot more. That's a fact.
Are we going to page 166 now?
So in 66 product standard, C 1325. And then look what it says about R value. Cement board does not contribute significant thermal resistance when used as part of a roof assembly. Then there, look at combustibility. Because you're gonna see some of these. Cement board is non-combustible, so it can be exposed directly to hot bitumen, torch, flame, or high temperatures. Then you have composite boards. the composite boards. On page 168, you have the standard 1289 ASTM standard for composite boards using the polyiso insulation. It's ASTM 1289. And then this is something that I think came into this new, the old version of the blue book didn't have. On page 170, talks about vacuum insulated panels.
Oh.
It's the
And there's-
VIP.
It's a VIP.
Wise ass.
Wow, it's true. I just read it.
Well, it is VIP.
It
Okay,
says
look at
the
that.
standard for VIP insulation is.
VIP insulation. Okay, now look at this thing. Product standard, the US product standard for VIP insulation is ASTM 1484.
It's a baggie.
And that's the only thing I have is because I haven't seen anything. The product, I just highlighted the product standard in there for that. And then you come to tapered, and tapered insulation has a few questions.
Hmm,
172.
my favorite.
Tapered
No,
insulation.
no.
And
Cheap.
then on
I use it enough.
Okay, that's okay. Although, look at tapered insulation starts right there, the last statement right above the bullet point. Although the primary reason for using tapered roof insulation is to improve slope and promote drainage. So the primary reason of tapered insulation is slope, improve slope and promote drainage. There are other advantages. So it can provide additional thermal resistance, increasing the energy efficiency of the roof system. And then on the second bullet point, certain tapered insulation per line of wood can serve as cover boards of a primary thermal insulation to provide mopping surfaces. So this is what tapered insulation can do. Then on page 1, talks about now design criteria, talks about substrates, the drainage, and then look at on the page 173, perimeter conditions of roof penetration and roof penetration. Now that humongous paragraph right there, 1, 2, 3, 4, 5, the sixth line into it.
8 inches.
Six
Right.
lines to the perimeter conditions and roof penetration. And you're gonna see something that you've already seen a couple of times already. Raised curbs must be designed for sufficient height above the tapered insulation to allow for a minimum flashing height of 8 inches.
8 inches.
See, again goes to the 8 inches. Then on the next column, look what your underlying minimum R value. This is the minimum R value approach establishes the R value for a tapered insulation system to be determined by the R value of the tapered material at the thinnest point in the tapered system layout. That's a little bit of common sense. Then when you turn the page from 174, the very top, average R value, right in the very top of the page. Average R value establishes the R value for a tapered insulation system by determining the R value of the tapered material as a representative average thickness of the tapered system layout. And then you have some paragraphs, different slopes and all that. And then you go all the way to page 179. And there's a couple of questions that have come up from this page. One of the questions is on the table right above, right there, recommended maximum length to width ratios for saddles and crickets. According to the slope, saddle material slope, their length to width ratio. Then when right on that column, the first column, all the way down to hips and valleys. When using preformed tapered insulation boards of one consistent slope. All valley center lines should be 45 degrees from the direction of the slope. And then the next couple of pages, you have different tapered insulation designs and all that. So this is insulation. Now we're gonna go to membranes. Now we're gonna be the membranes. Chapter 5, membranes. And then you're gonna see information that we've already seen at the beginning of the book. On chapter 5, look at 5.1, page 186, guidelines applicable to all membrane types. And when you see that slope and drainage, again, look at the same information we saw at the beginning of the book. The International Building Code 2021, indicates design minimum slope, quarter in 12 is required for membrane roof systems, except coal tar built-up roof, which is 1812. Remember one thing though, our Florida Building Code is patterned after the International Building Code.
Oh, yeah.
Okay.
Florida had it just,
There was a time that you guys remember there was a time that was not. We had the South Florida Building Code.
2007, right? 2007 was the first one, right?
There was, the little three binders.
Yeah,
the little three
the
binders.
little one.
South Florida Building Code. Yeah.
Now,
No, look at that now. Well, now actually, if the code is 9 books altogether, the Florida Building Code, 9 humongous books. Of course, what is the beauty of it is that it's online,
yes.
and you can go back to what the code used to say from the previous codes. So it's pretty good. Okay, now look at 186, talks about the slope and drainage, and then the following paragraph talks about positive drainage. Look at the second line, the criteria for judging proper slope and drainage: no ponding water on the roof 48 hours after a rain event. So here it tells you exactly the same thing it was at the beginning of the book. Then we're gonna
48 hours.
Yeah, 48 hours. Positive drainage, 48 hours. Minimum height on flashing height, 8 inches. How long do you have to report a death to OSHA?
What?
Death or injury?
One is,
Death or
and
injury?
the other one is
Death.
4.
Death is 8 hours.
8 hours.
See, that's another one.
Injury is 24.
Injury,
Mike,
24.
I have a kindergarten question for you guys who has been doing roofing for years. What is the definition of a positive drain? Why positive drainage? Why do they call it positive
Okay,
drainage?
what happens is this. That means that it drains. In other words, there's some
That
roofs,
goes away.
One of the roofs we did not long ago, I had a roofer do a roof in a brand new building. We used tapered insulation, but at one edge of the building, instead of bringing it up, there was a puddle of water for about 3 or 4 days.
Oh, God.
So what happened? Booby, I'm sorry. You had to come over and you had to fix that. Because
No
it has
scupper?
to drain. Positive drain means that the roof is going to be dry within 48 hours.
Okay.
Rain, you have some puddles. Okay,
Mhm.
there's that's what it says. They say 48 hours. The sun is out, no rain.
Within
The
those
puddle dries
48
up.
hours.
That's
Yeah,
positive.
within, yes,
If it
okay, I
stays with
understand.
water, then it's not positive drain. That's what it is.
Okay, see, it was a kindergarten question, but I'm glad you guys answered.
No,
Thank you.
that's what it is. You know,
All questions are good questions.
every question. The only question that is no good is the one that's not asked.
You don't ask.
Right.
No, I was just wondering why positive? That means because it has to be gone, right?
That's
It
what
has
it is.
to,
It
it
is
has to
drainage.
be,
Right. In other words, the roof
Okay.
drains. The roof is acceptable for drainage.
Mhm.
Because you have
Positivity,
that thing
man.
so smooth. It's not
Yeah.
gonna be smooth, so they allow for whatever little puddles in there.
Thank you.
Didn't it used to be positive drainage, then it changed to a 1/4 inch slope, and now it's back to positive drainage?
Yeah, well, actually, the 1/4 inch slope is still that. It's still there. But what happened is when they were doing some of the slope, in order to be able to slope it to the drain, in one portion, one end of the roof, for some reason, whatever it is, they ran out of tapered insulation or something like that. It was too flat. In other words, the water stayed instead of running.
Uh-huh. Was it a concrete deck?
It was a concrete deck, and then you had
They may not have screeded the concrete correctly at that point.
right, but no, actually, they had the tapered insulation probably.
Oh,
You know, it was tapered insulation, and they tried to get it in there. Everything worked perfect, but one darn little corner that the water stayed there. I wanted to go there and try to clean it up, but I couldn't. I had the big boss with me at that time. I couldn't do it. Anyway, we're going to be looking at built-up roof membranes. This is the first type of membrane that we're going to be looking at.
What page?
It starts on 187.
what works in roofing?
Built-up,
Redundant reinforcements.
right. So now look at 188 bitumens. The principal bitumens used for built-up roofing membranes are cold applied asphalt adhesive, cold applied polymeric adhesive, hot applied asphalt, and hot applied polymeric modified asphalt. Polymer modified. Then talks a little bit about asphalt. The second paragraph underneath the bullet points. Asphalt derived from petroleum. You know. Okay. Now look at the fourth line into that paragraph. Hot applied asphalt and hot applied polymer modified asphalt are thermoplastic in nature. That is, they become fluid with heat and revert to solid state when cool. Then asphalts have excellent resistance to moisture, good resistance to weathering, excellent cohesive and adhesive characteristics. That is there. Then we're going to go to the different, cold applied polymeric adhesives that start on page 189, but then it goes to 190. And 190, you have a few of these, a few little changes on the ASTMs too. If you look at the first column, 1, 2, 3, the fourth paragraph, currently no ASTM standard specifications applicable to cold applied polymeric adhesives. They don't have any ASTMs yet.
Wait, I think I got lost.
Okay.
The
190.
last paragraph on 189?
No,
On
it
189,
starts
no,
on
no, no. It starts there.
But go to
So
190.
what it came, the question came from 190. Starts on the cold applied. Is still talking about the cold applied polymeric
Fourth paragraph.
adhesive. Then there are no ASTM
I
specifications.
got it. Thank you.
Okay, then on the next column, you know, you're talking about the refinery, right at the top about, look at the 500 degrees. At the refinery, raw asphalt flux is heated to about 500 degrees. And air, so on, so 500 degrees, raw asphalt is heated for that.
You said the second column? Oh, yeah, okay.
Yeah, the
okay.
second column.
Yeah, first column, first paragraph.
Then you're gonna see the US product standard for asphalt use in roof system application, ASTM D312. And classifies it into 4 types. And you can see the asphalt softening point, the 4 types there, and you're gonna see a table on the softening point for the 4 different types of asphalt. And usually you have the minimum and maximum softening point. Then look at the last paragraph on that page, on page 190. Currently, asphalts conforming to ASTM D312 type 1 and 2 seldom are used for built-up membrane construction in the US. However, they're used in Canada.
Hold.
They are. Then on the next page, underneath the asphalt penetration and the ductility, asphalt's flash point temperature, which is that little paragraph below that. Look at the fourth line. FP temperatures is the lowest temperature on which vapors above the volatile combustible substance can ignite in air when exposed to an ignition source. And then it starts explaining historic guidelines have established an asphalt flash point temperature minus 25 degrees as the maximum desired heating temperature in an asphalt kettle tanker.
You've seen that question.
25 degrees less than the the
So
FP.
minus 25 degrees is the flash point?
Yeah, the flash point is 25 degrees less than what the flash point is. What happens, that's how
Oh.
far how hot you can get the tank,
It's a
the
safety
kettle.
temperature.
Right. Okay,
Oh,
but
okay.
now what has happened then late, what you see on the next paragraphs there talks about historically. Okay, the flash point used to be at 500 degrees Fahrenheit.
Right.
But then if you look at the end of that next paragraph, which says as a result, because there were some issues with 600, 575. As a result, ASTM D312 now indicates a maximum heating temperature for asphalt as 550. So they changed to 550. Then the next paragraph talks about the equiviscous temperature. This is for hot applied asphalt built-up membranes applications, nrca historically has and continues to endorse the equiviscous temperature range concept for measuring and identifying asphalt's viscosity and preferred application temperature. The ASTM for that is D4402. See it right there in the middle of the paragraph.
Mm-hmm.
And this is another one of the questions that if you don't read the whole thing, you're not going to answer correctly. Look at two more lines underneath the 4402, the third line. For MOP application of asphalt, EBT has been established at the temperature in which asphalt has a viscosity of 125 centipoise. So you're going to have that on the, But for mechanical spreader application, the EBT has been established at the temperature 75 centipoise. And then you see the same thing on the table underneath, according to the two types of asphalt. See, 125 and 75. MOP application, mechanical spreader. The way the table is divided. And again, a lot of people would answer the 125 and forget the 75, and they're probably asking you for mechanical spreader application. That's the type of thing. Okay, now, again, look at page 192. Second paragraph. nrca recommends asphalt be applied in the field within plus or minus 25 degrees range from the asphalt's indicated EBT.
So they're all about the same, plus or minus 25.
Plus or minus. The other one is 25 degrees
Less.
the flash point. You want to keep it
Oh,
below that
okay.
so it doesn't ignite. But here you could go plus or minus the EBT.
Got it.
Then 1, 2, 3 more paragraphs below that one. And talks about ASTM D312. Then look at the fourth line in that paragraph. Asphalt complying with ASTM D312 type 3, generally appropriate for interply moppings in built-up membrane applications, where the slope of the completed membrane is 1 in 12 or less. That's one. Use of asphalt complying with ASTM D312 type 4 is suggested for slopes greater than 1 in 12. Got to make sure the one, which of the two? 1 in 12. 1 in 12, I'm sorry. Then hot applied polymer modified asphalt, hot applied polymer modified asphalt on the next column. And there, the polymer, about the fourth line, the polymer modified asphalt is made from standard roofing asphalt modified in addition with styrene, ethylene, butadiene, styrene, SCBS. So this is what that is. And then, but the standard for SCBS on hot applied polymer modified asphalt is on the second paragraph. The U.S. product standard for hot applied SCBS modified asphalt using roofing, ASTM 6152. And then the same thing we've seen already with the hot applied modified asphalt. Look at page 193 on the top, the very top of the page. nrca recommends kettle and tank temperatures be maintained lower than 25 degrees below the asphalt's actual flash point, and never heated to or above the actual flash point temperature. Then you have reinforcement felts and sheets, and you have three types of sheets on the page on the second column: base sheets, ply sheets, and mineral surface cap sheets. Then on base sheets, look at the third paragraph, the fifth line on the third paragraph right there. On wood and other nailable roof decks, a base sheet works well to help cover joints on a roof deck to prevent bitumen drippage. Mechanically fastened to the deck, a base sheet can provide an acceptable surface onto which the remainder of the roof system can be assembled. Provide drippage. Then you're gonna have on the base sheet, you have one that starts on the bullet point right there on 193, asphalt coated fiberglass matte base sheet. This is the asphalt coated matte base sheet. Look at the on the next page, 194, the last statement on that bullet point, ASTM D4601 is the standard specification for asphalt coated glass fiber base sheet used in roofing. Then on the next bullet point, the last statement on that next bullet point, ASTM 4897, standard specification for asphalt coated glass fiber venting sheet used in roofing. One is a base sheet, the other is a venting sheet. And then we go all the way to membrane flashings, 196 APP polymer modified bitumen sheets on 196. And there you have three different types of ASTM designations. And they give you actually on the test question, there are a few of them that have three different types of ASTMs, and they go back and forth. And there you're gonna see ASTM 6222, 6223, and 6509. That is for APP, polymer modified bitumen sheets. Now look at the next column, it talks about the SBS. And the SBS, which we've already seen it, it is, styrene, butadiene, styrene polymers modified. ASTM 6162, 6163, and 6164. Slight difference between the two.
Yeah, one's polyester and glass, one's polyester and one's
Exactly.
glass.
Right. Then on page 198, polymer modified bitumen flashing adhesives. Flashing adhesives. The second paragraph on
Where is that?
top,
197?
198. Yeah, already 198.
Okay.
198. Polymer modified bitumen flashing adhesives. The second paragraph, the seventh line, into that second paragraph. It says the flashing grade or high viscosity adhesives typically are used to bond membrane flashings to vertical or steep slope substrates, vertical steep slopes, when you use polymer modified bitumen flashing adhesive. Then on page 199, you have bitumen heating. And there, what I would do is just highlight the bullet points. Maintain the kettle temperature tanker at 550 degrees or lower. Circulate the bitumen, but just highlight the bullet points. Now, this is something that has been, you're going to see it a couple of times, but in here, this is what talking about cold applied adhesive storage handling application. Look at membrane application on page 199 towards the end of the page. Membrane application. Then about the third line. At the end of the third line, when possible, all ply should be installed in shingle fashion. When slopes are greater than 2 in 12, consideration should be given to laying the felts parallel to the slope. This application method, consisting of plies laid parallel to the slope, is referred to as strapping the plies.
Strapping.
And may also be used on slopes of less than 2 in 12. It's called strapping the plies.
Yep, we had that yesterday.
We had that question.
Yeah. Strapping the plies.
Yep.
Okay. That's what it is. But and not only that, and it's repeated in a couple of places in the book, but this is what I had it. This is why I highlighted it in there. Then now you're going to go to 5.3 polymer modified bitumen roof membrane. And there, look at on the polymer modified adhesives on page 201, and then cold applied adhesives on the polymer modified bitumen roof membranes. Look at the fourth line. When an asphalt is thinned with solvent, its material state changes. What was once a solid material at normal ambient roofing temperature becomes liquid material. And this is what it comes from. These liquid versions of asphalt are referred to as cutback, or cutbacks. Cutting the asphalt back with solvents makes it possible to apply the asphalt adhesive without heating it in a kettle tank. They call the cutback asphalt. Then two ASTM's designation for the cold applied asphalt adhesives. You're going to find them on page 202 on the second column, the third paragraph. You got two of those. ASTM D3019, which is standard specification for lapped cement used asphalt road roofing. Or ASTM 4479, standard specification for asphalt roofing coatings, asbestos free. Then, and you're gonna see, we already seen that already on the cold polymeric adhesive cold applied. There's no nrca specifications. We already see it before. 203, look at the end of that column. Currently, no ASTM standard specifications applicable to cold applied polymeric adhesive exist. Then we have hot applied asphalts, hot applied mop. Okay, on hot applied asphalt, we talk about D312 again, we saw that. But then in 204, base sheets, base layer, base sheets. On the base sheet, look at the second column, right above the bullet points. The following base sheets are used with polymer modified bitumen roof membranes. Typically, I would have to go to the base sheet that they call me. This is for polymer modified roof membranes. And there to look at the ASTM designation. D4601 standard specification, asphalt coated glass fiber base sheet used in roofing. And then the one below goes to the venting. 4897 standard specification, asphalt coated glass fiber venting base sheet. I think it's a repetition, but I mean, they're there. Then on the next, there's another bullet point there, SBS polymer modified asphalt coated base sheet on the SBS. And look at the second paragraph there. The US product standards applicable to SBS polymer modified bitumen sheets depending on the reinforcement. 6163, we already seen it, before.
Right.
6163, 6164, and 6509. And those are the three. If you go back, I'm going to tell you where. Actually, we didn't highlight it there. I have it highlighted here because that's where it came from. But you have 6163, 6164, and then on the next page you have the 6509 on the next column. I'm sorry. The three specifications for SBS polymer modified asphalt coated base sheet. SBS, I'm sorry. The SBS you have this too. Then the other one is the APP. That's what it was. APP polymer modified coated base sheet 6509. My bad. So just have them highlighted. Now you're going to see some slight differences. 206. SBS polymer modified bitumen interply sheets. Not the base sheet, but the interply sheet. And there you have on 207, 3 of them. I'm sorry, I got the APP also that I didn't have highlighted. Look on page 205. APP polymer modified, you're going to see the 3 of them. I'm sorry. On 206 on the bottom, APP polymer modified interply sheets. On the very bottom of that bullet point, 6222, 6223, and 6509. Those
Or the
three.
bottom of 206.
Interply sheets. On page 206, towards the, at the end of the first column,
Okay.
on the second column. Just look for the SM designations that way you have it. But that is the key there is those are interply sheets. Polymer modified interply sheets. Then this is APP. Then the SBS, which is starts in 206, but the three ASTM designations are in 207, which is ASTM 6162, 6163,
That's SBS and
and 6164. That's for the SBS. And then you could see him kind of a repetition. Now, polymer modified bitumen cap sheets. The cap sheets. And the standards for the cap sheets, you're going to pretty much 6162 on the bottom, 6163 for the polymer modified, 6164.
For the cap sheets?
These are cap sheets now. Polymer modified bitumen membrane cap sheets on the second column.
I jumped to the other self-adhering.
Yeah. So
Page 207.
It has base sheets, interply sheets, and sometimes they're repetitious.
Right.
Sometimes they're not. So this is what it talks about cap sheets now. you see in the bottom, the standards 6162, which is 6163, 6164, and 6298.
Mhm.
That is for SBS. Then APP, the other three. Underneath that, ASTM International, standard 6222, 6223, and 6509. Okay, so these are the different sheets. Now we're gonna go to accessories. Accessories. On page 209, bituminous roofing cements. Look at at the end of the third line. Bituminous roof cements sometimes are referred to as plastic cement, roofing cement, or roofer's cement.
Right paragraph?
Okay, on this, you know, where it says in accessories, bituminous roofing cements, in the third line, right there.
Mud,
You find it?
this is the mud. Tar,
Yep.
whatever.
You know, what do you call it?
Plastic roof cement.
Yeah,
Yeah, what do you call it when you go to Home Depot and buy a can of,
Tarnet.
there you go. Okay, now look at the next paragraph below that. Horizontal grade roof cements are used for embedding metal flashing flanges and forming seals at penetrations. Typically. Then on 210, the ASTM designation for the cement. Page 210 in the very top, the first full paragraph there, above polymer modified bitumen flashing adhesives. Asphalt roof cements should never meet or exceed the standard set forth in ASTM 4586 for asphalt roof cements. Then polymer modified bitumen flashing adhesive, polymer modified now. On polymer modified, the second paragraph, 1, 2, 3, 4, 5, the sixth line into the second paragraph. The flashing grade or high viscosity adhesives typically are used to bond membrane flashings to vertical or steep slope substrates. And then the end of that paragraph, there are currently no ASTM standards for polymer modified bitumen flashing adhesive. Then we're gonna go now application. Okay, application polymer modified bitumen membrane materials. But we're gonna go to page 212. Bitumen heating. When SBS polymer modified bitumen membrane materials are specified to be installed in hot bitumen, the EVT range recommendation generally is not applicable. So what is the EVT range for SBS polymer modified bitumen membrane materials? None. You have 25, 75, 1, you know, all of those, and then 0 or none. And that would be the answer. Then torch applied application.
I lost you there in the previous.
Okay, there, starting on page 211 on the bottom, you talked about application for polymer modified bitumen membranes. You got fasteners for the membranes. Then on the next page, page 212, bitumen heating. See it?
Yeah, go ahead.
Yeah, okay, no, that's what I make sure.
Yeah.
Yeah, okay, they basically, there's no EVT, not applicable. Then torch apply application, torch applied application, which is in the next, for cold applied adhesive storage and handling, torch applied application then. In torch apply, which is something that is redundant kind of, but anyway, I have it highlighted. So the second paragraph, the third line, the potential for fire is of specific concern during the installation of torch-applied membrane sheets over combustible substrates such as wood roof decks, wood blocking or wood panel sheeting, wood planks or boards. Then,
Really, wood is combustible?
huh?
I mean,
Well, it says there, so I have it highlighted for some reason. They had to be there. And then two more paragraphs below that. NRCA recommends the application of torch-applied polymer-modified bitumen sheet products follow the CERTA roofing torch safety program guidelines. I have never seen anything coming out on CERTA or something like that, but some information on that is in chapter 10 on the details. Now here you're going to see membrane application, and you're going to see information that is repeated again. A membrane application, look at the second paragraph on page 213. On lower slope roofs, a membrane should be applied so the flow of water runoff, so and so. Now, the third line, when possible, all ply should be installed in shingle fashion,
Correct.
right?
Yes.
Then continuing on that particular paragraph, 4 more lines below that, 3
When
more
the
lines
slope.
below that. When the slope is greater than 212, consideration should be given to laying the plies parallel to the slope.
Strapped.
Right, strapping the plies. You see, well, it repeats what we've already seen, strapping the plies.
However, there are some bi-reinforced modifieds made in Turkey that when you roll them out horizontally on a sloped roof, they run straight, they don't run off. And that's the only modified bitumen that I've ever seen that ran straight on a slope.
Really?
Yes. And
Well,
and
I'm
the
sorry, I'm not going to Turkey to see it.
well, they're less expensive than US made and they're higher quality.
Yeah,
Lower
but I live here.
melting point. I used to import them by the container.
Wow,
426 rolls.
that's a heck of a lot of rolls.
That's a lot of rolls.
Oh my God,
Believe me.
that's a lot of rolls. Take a look at the next to the last paragraph on
And
that.
they're approved to use here.
The strapping the
Oh.
plies. Yeah, we look at the strapping the plies, then in 213, then first column, the polymer, the next to the last paragraph. Polymer modified bitumen cap sheets generally applied in a staggered end lap configuration method or with a line end lap with a header sheet method. Then the next question starts, the information starts at the very end of page 213. Blisters have been reported in some SBS polymer modified bitumen membrane systems. That's what they're talking about, blisters. But when you see the next page, right
Comes-
underneath the figure, the
Comes from
second,
phasing the roofing.
huh?
You get blisters with SBS when the roofer phases the installation.
Yeah. Well, look at it now. Application factors that contribute to blistering include insufficient asphalt temperature at the point of application, long knob lead, and lack of cap sheet embedment into the asphalt mopping.
Wow.
Then 3 more lines below that one. Mob lead is a critical factor because if it's too long, the asphalt may become too cool and adequately, to adequately bond to the SBS sheet when contact is made.
Mhm.
So this is all the bituminous type of materials that we use in in low slope roofs. Now we got single ply roof membranes. Single ply. In page 215. And then look at the third or the second full paragraph on the second column. There are two principal types of materials used in the construction of single ply roof membranes: thermoset polymer sheet and thermoplastic polymer sheet, right?
Yeah,
Then the next paragraph, what they are and how they're put together, or how they're sealed. For thermoset roof membranes, the material principal polymer is chemically cross-linked. The chemical cross-linking of thermoset membrane means once the sheet material is cured or vulcanized, it cannot be softened to bond with itself and cannot be reshaped. That's thermoset. Now, if you look at the next paragraph, look at 1, 2, 3, 4, the fifth line. Unlike thermoplastic materials once fully cured, thermoset polymers can only be bonded to like material with liquid applied adhesive or glue or adhesive seam tape because new molecular linkages may not be formed. So this is your thermoset type roof. Then, and this is one of the test questions that you still see, this book only deals with EPDM for thermoset roofs. But if you look at the next paragraph, look at what it says, refer to the nrca Roofing Manual Membrane Roof System 2015, and you have two more, CSPE and PIB. They were also thermoset, because I believe there's a test question that says, which of these is thermoplastic? And they gave you these three, and then TPO, or PVC, something like that, which is thermoplastic. So they gave you EPDM, CSPE, and PIB, all the way around. Which one is its thermoset? And they give you three thermoplastic and CSPE. What the heck is that? That's where you find it. They used to be, but they're kind of phased out.
aren't they ever?
Yeah. Then on the next page, 216, look at the very top, at the end of the first line on 216, because of the chemical nature of thermoplastic materials, thermoplastic sheets typically are seamed by heat welding with hot air. Then there are four common subcategories of thermoplastic membranes: PVC, PVC alloys, KEE, and TPO, or ketone ethylene ester. Then on the next, now you're going to talk about EPDM, right underneath. But on the second column of talking about EPDM, says EPDM membranes exhibit good resistance to ozone, ultraviolet rays, weathering, and abrasion. So EPDM also has good low temperature flexibility. It is resistant to some acids, alkalis, oxygenated solvents, such as ketones, esters, and alcohol. Then on the other hand, exposure to aromatic, halogenated, and aliphatic solvents, as well as animal and vegetable oils and petroleum-based products, should be avoided to prevent membrane swelling and distortion. So here it tells you what they're good for and what they're not. Then the next paragraph below that, EPDM sheets used for roof system applications commonly are black in color. Then the next one, sheet range in thickness from 45 to 120 mils. And the most common thickness of EPDM single ply roof sheet is 45 to 60 mils. On the very bottom, you have the product standard, ASTM D4637 for EPDMs. Then 217, 1, 2, the third paragraph still deals with about the same thing. Field lab seams in EPDM roof membranes typically are constructed with adhesive seam tapes.
Where is that?
On page 217, third paragraph. Field
Do we have
glassing.
time for a little anecdote about EPDM?
Come back?
Do we have time for a little anecdote about EPDM?
Yeah, why not?
It was invented in England in 1958, and the colorant that they chose was carbon black. At the time, they didn't know the value of the carbon black, but it turned out to be one of the finest ultraviolet inhibitors ever discovered by man. And so EPDM really never wears out. I have systems out there that are over 40 years old, and they haven't failed. They need preventive maintenance, yes, but they have not failed. Now, if it's formulated off ratio, it will fail and you can tear it. There are a few years when Firestone mixed EPDM off ratio and you could tear it. It just pulled apart.
Really bad.
Other than that, it lasts forever.
Mike, repeat that again.
I think my first
Third
experience,
paragraph.
something like that, was about 85, but it was on, I think it was either when it started with TPO or one of those, what it called thermoplastic types.
Uh-huh.
Because I remember I was a superintendent in an 11-story building. When the roofer came in, they wouldn't even let us get on the roof with our shoes. We had to take off our shoes to be able to walk. That thing had done away. That thing was like, that was in Austin, Texas. And that was like the first time I saw in, single ply membrane. I think it was TPO or either it was TPO or something like that. It was
You
not
want,
thermoplastic. It was not thermoset. It was thermoplastic because they heated it.
do you know the story behind TPO when it came out in 89?
Yeah. So
It
it had
was
to be something.
it was 45 thousandths thick,
Yeah.
and it failed due to excessive heat aging. It had surface crazing, so they added more ultraviolet inhibitors, put it back out on the market. It
60
had
days.
surface grazing again, so they added more ultraviolet inhibitors, put it back out on the market. Goddamn, failed again for the same reason. So then they increased it to 060, adding more ultraviolet inhibitors, and now it's kind of stable. But it's junk.
It gives you, but they give you a heck of a warranty.
Well, the warranty is great, but is the membrane going to last that long?
Well, that's why. Yeah, that's. I know. I hope they don't call me back.
So the clue is to always work with a standard of quality in the roofing materials that you use.
No, of course. Now look at this
Mike, could you go back to that for a moment? You said it was the third paragraph.
third
Yeah.
paragraph. Lap seams, EPDM, typically constructed with adhesive seam tape. Okay, then on the next column, the third paragraph or the second full paragraph. Now we're talking about, I'm sorry, PVC starts on the bottom of the first column. So we're going to look at PVC sheets. And on the second full paragraph on the second column, PVC sheets resistance, what are they resistant to? Bacterial growth, industrial chemical atmospheres, and plant root penetration. And then 2 more lines below that. PVC sheets are chemically incompatible with bituminous materials such as they should be separated from asphalt products. Then 1, 2, 3 more paragraphs down gives you the thicknesses. PVC sheets produce in range 30, 36, 45, 60, 72, and 90 mils. Then nrca recommends design and specify sheets. Nominal thing is 45, conventional single ply roof system, 45 mils. I think it's too thin. But anyway. Then on 218, the product standard on the second there on the first column, second paragraph is a D4434. Then you have PVC alloys. The PVC alloys talk about 3 of them: CPA, EIP, and MBP, copolymer, ethylene interpolymer, and nitrile alloy. These are the alloys. Then on the next page, you got KEE, ketone ethylene ester. And then look at the very bottom of page 219, the two-liner that continues on the next column. KE sheets generally resistant to certain chemicals, air conditioning coolants, jet fuels, and membrane and restaurant grease, as well as UV radiation, airborne bacteria, acid rain, and industrial pollutants. So usually that's, what sheet, what type of roofing, single ply membrane is resistant to restaurant grease. They give you what, or what specific sheet is resistant to or not. So this is the type of questions you'll be able to see in these type of things. Then on the same column on 219, 1, 2, 3, 4, 5, 6, the 7, the 3-liner there, KEE membrane labs seen by hot air welding according to specific manufacturer recommendation. Then on the next page, you have what everybody, I guess, gets to know, TPO. And a TPO, 1, 2, 3, 4, gives you the thicknesses, available in range, nominal thickness 45, 60, 72, 80, and 90 mils. Then 2 more paragraphs below that, towards the end of the paragraph, the big one, the nrca recommends, and look for the 60 mil, recommends designers specify minimum nominal 60 mil thickness TPO sheets or thicker for project conditions warrant. And then on the very bottom, the EOS product standard, the ASTM 68D6878. Then application of single ply membranes. The last paragraph on that column right there in the second column. Single ply sheets, about the 4th line, should be unrolled and allowed time to relax and be flat and lie flat before application. Manufacturers commonly indicate a minimum period of 30 minutes for this. You'll see that a lot on your waterproofing sheets.
Mhm.
I was missing the 30 minutes relax before
We were
use
missing
already.
the 30 minutes, right? Then on page 221, loose laid. Now, the application of single ply membrane, you have loose laid, mechanically attached, ballast, something like that. So on the loose laid ballasted, on 221, the first full paragraph on the second column. The most common application rate for aggregate or stone ballast is 1,000 to 200 pounds per 100 square feet for 1.5 to 3/4 of an inch round river wash gravel designated size number 4 in ASTM D7655. Number 4 gravel. Then you have mechanically attached. I don't have anything mechanically attached. Then you have, no, mechanically attached, I don't have anything. Then you have heat induction welding, which is this is one of the came up in this book, 224. Heat induction welding. And in heat induction welding on 224, look, it says an alternative method of mechanical attachment of single ply roof membranes is heat welding a thermoplastic single ply roof membrane to specifically coated fastening plate using an electromagnetic heat induction welding tool.
That's it.
Hmm?
I've never
Then-
seen that.
Then on the same column, 2 more paragraphs down after the big one, manufacturers vary regarding insulation board. However, nrca recommends roof insulation be installed in multiple layers and the top layer be laid so the board joints and continue straight, both direction, not in staggered patterns, so differently.
Huh,
What page is that?
Okay.
Two,
When
two,
you see on
four.
the same, on 224,
Right column.
you have on the second column, you see at the beginning of the paragraph, the second full paragraph, manufacturers vary regarding insulation board layout. Then NRCA recommends, however, roof insulation be installed in multiple layers and the top layer be laid out where board joints are in continuous straight line in both directions. Completely different than the other type of insulation that you want them staggered.
Is that for all roof systems?
No,
On
this is
the
Or
heat
just single ply?
induction welding.
Induction welding system.
Okay, got it. Thank you.
Okay. Then the last paragraph on the page, heat induction welded roof systems may be installed directly over insulation boards that will not melt by the welding process, such as fiber reinforced gypsum board, glass face gyp board, stone wool, and polyisocyanurate. Then on page 227, page 227, on the first column, look at the 1, 2, 3, 4, 5, 7. Designers should keep. So it says designers should keep in mind a heat induction welded roof system is not appropriate when energy concerns warrant eliminating thermal bridging or when a roof assembly is required to have air barrier. Continuing.
I did not find that.
Okay, look at 27.
Yeah, 227, I'm there.
Underneath, on the first
Oh,
column,
the last.
about the 7th line, designers, the last 4 lines on the first column.
I found it. Designers should keep in mind a heat induction welded roof
Yeah.
system is not appropriate when energy concerns warrant eliminating thermal bridging.
Or when a roof assembly is required to have air barrier.
Thank you.
Of course not. Then NRCA recommends designers specify PVC, KEE, or TPO membranes such with a minimum thickness of 60 mils for heat induction. Then on page 230, now we're going to have water-based adhesive. Well, let me see. Now we're going to be talking about water-based adhesives. Page 230. You see the underline right there. Water-based adhesives. Water-based single-ply adhesives typically are acrylic latex emulsions. On the next 230, the next column, the second column, 1, 2, 3, 4, the 5th line. I mean the 5th paragraph. 2, 3, 4, 5. Manufacturers generally recommend water-based adhesives be transported and stored at temperatures between 60 and 90 degrees Fahrenheit. Paragraph below that. Manufacturer instructions warn against using water-based adhesives when there's a possibility of freezing temperatures within 48 hours after the application. Of course, water-based. Then 232, liquid applied roof membranes. So on the second column, the 3 components, the principle on using in construction liquid applied roof membranes are liquid resin, reinforcement, and accessories. Then liquid resin. Right
Hold
underneath.
on. Sorry, I lost you there. So 5.5.
232, 5.5. Look at the second column.
Oh,
Three
you jumped?
Oh, the
Three bullets.
second column.
The 3
Okay.
bullets.
The 3
The
components.
3 bullets.
Liquid resin, the 3
Beautiful.
bullet points. And then underneath, you're talking about the liquid resin.
Okay,
And at the
I'm
end of
with you
that
guys.
page, then the end of the page, following continues to the next page. With unsaturated polyester and polymethyl methyl acrylate based resins, the catalyst is added to a liquid resin or primer to induce the curing process. The catalyst. Then on the second column, right above reinforcement, the two paragraphs right above reinforcement, still talking about liquid resin. Currently, there are no ASTM international standards for liquid applied roof membrane material. Then liquid applied roof membranes generally are installed in 70, 80, 90, or 115 mils finished thickness. You know, when they apply the thickness. That is chapter 5. Then we're going to go to fasteners in chapter 6. I don't see it mention fasteners until we get to page 247. The only thing I have in fasteners. On page 247, it talks about fastener spacing. Then look at about the fourth line, common fastener spacing within a row, 6 inches and 12 inches.
What page?
On page 247, talks about fastener spacing. The fourth line says common fastener spacing within a row is 6 inches and 12 inches. Common fasteners, the common ones. Then chapter 7 talks about surfacings. What are we going to put on top?
We're skipping the surfacing.
Chapter 7, page 253. Still not much more to go. In chapter 7, surfacings, says at the very beginning, membrane surfacing is a component that protects the waterproofing component of some roof systems from the effects of direct sunlight, ultraviolet rays, and weather exposure. Some surfacings provide other benefits, such as increased fire resistance, improved traffic and hail resistance, and aesthetic properties.
Wow.
Then on 7.1, page 254, it talks about guidelines applicable to all surfacing types. And there you see the 3 bullet points. The Cool Roof Rating Council has, rating based defined properties: emittance, reflectance, and solar reflectance index. Those 3 bullet points. Then on the second paragraph, the second column underneath that figure, solar reflectance values determined by using ASTM C1549. On the next paragraph below that, thermal emittance values are determined using ASTM C1371. Then
71.
you see it?
Yeah, 1371.
Okay, and then the next paragraph below that, you saw that? A roof system surface texture, color key factors when determining a solar reflectance system of the product. A roof, 2 things. A roof surface texture and color are key factors when determining the solar reflectance. Then a roof system material type and thickness are the key factors when determining the thermal emittance of a roofing product. One is the solar reflectance, the other is the thermal emittance. Then on page 255, and this talks about now aggregate on the surfacings, aggregate and aggregate surfacing applications right at the end of 255. Look at the 1, 2, 3, 4, the 5th line into that little paragraph. Asphalt flood coat application rate typically is approximately 60 pounds per 100 square feet. Now, aggregate surfactants may be either, starts there, but then you'd see the bullet points on the next page. 2 types of aggregate surfacing. Approximately 400 pounds of gravel for 100 square feet. Then it says with an add here, the aggregate weight of approximately 200 pounds per 100 square feet. approximately 300 pounds of slag per 100 square feet with an adhered slag weight of approximately 150 to 2 pounds per 100 square feet. Then you have a table for aggregate gradation. There you have ballast. Ballast, take a look at the end of the second paragraph, the last line on the second paragraph. Generally, ballasted roof systems are limited to roofs with slopes of 2 in 12 or less. Then when it talks about aggregate ballast, typically 1.5 inch nominal size, ASTM 7655. It's basically number 4 ballast, for aggregate. Then the following paragraph, the last one on the page, number 4 aggregate ballast typically applied at coverage rate of about 1,000. We see that already. 1,200 pounds per 100 square feet for loose laid ballasted membrane. Then on page 257, paver ballast. When using concrete pavers as ballast, pavers should be minimum 2x2, compressive strength of 2,600 pounds per square inch, and a weight of minimum 18 pounds per square foot. Coating. Then we're going to be talking about coatings, and in coatings, all the way up to 266 and 267. Coating application, 266 on the bottom. 3 ways of apply coating: airless spray, roller, or brushable. But then the table, the coating table, there you're going to have the type of coating and according to the membrane type. What is recommended, what is not. So maybe it couldn't be. Then you're going to have roof accessories, chapter 8.
Yeah, this is a little one.
Which one?
No, I'm saying this is a little
Oh,
one.
the chapter is a little one, yeah.
Yeah.
And then chapter 8 talks about accessories. And the first one is equipment curbs, but that is in page 272. Page 272.
24.
Huh? Oh. Look at the second paragraph. When mechanical equipment units are mounted on a roof, crickets are recommended on the uplights of the unit curbs 24 inches or wider to promote adequate drainage. Something that you remember the green book, 24 inches for, crickets. Here it is. And then 2 more paragraphs below that talks about the maximum amount of space should be provided. The third line, NRCA recommends minimum 24 inches of clearance between walls and curbs, minimum of 12 inches of clearance between pipes and curbs. If you want to keep on looking for, and it's the same thing, for most membrane roof systems, equipment curbs should be detailed in construction to a height of 8 inches above the finished roofing membranes. Then in the next column, you have expansion joints. And an expansion joints, look at the very bottom of that second column on the bottom of the page, 272. For most membrane roof systems, expansion joints should be detailed in construction to a height of 8 inches above the roof membranes. Then you have skylights. And on skylights and roof smoke hatches, the second paragraph, the second column, 1, 2, 3, the fourth paragraph. Second column, fourth paragraph. Skylights and hatches should be installed with curbs tall enough to allow for an 8-inch vertical flashing height.
There you go again.
8 inches, 8 inches, 8 inches.
It's on mine.
Then
There you go again.
re-roofing, 279.
Wow, we're on fire. It's 9 o'clock and we're still keep on
You
going.
know,
Let's
you know,
go.
this is,
We're
we have
cooking,
to
baby.
have-
We're
you know,
cooking.
I think for a couple of more, we have about 2 or 3 highlighting more to do, and that's it.
Okay, let's do it.
So let's
We're
finish
with
with the
you.
book. You guys don't mind, right?
No, let's go.
Estamos contigo, Miguel.
Okay, good. Look at on page 279, the second paragraph. 9.2, evaluating of existing roof systems. NRCA recommends such evaluation roof system for re-roofing be made on project-specific basis conducted by a roofing professional. I mean, I think the question came by an engineer, by an inspector, by a roofing professional.
But not an architect.
Not the architect, not the
No,
engineer,
sir, baby.
Which,
not the inspector,
which-
not the,
where's that?
not the,
Where is that
9.2
again?
evaluation.
279.
Under
Yes.
9.2.
9.2, second paragraph, and talks about a roofing profession.
roofing professional? Okay.
Yeah,
Roofing
like
profession.
you.
Then
That's
we're gonna go
not,
to
that's not what
details.
she said.
Then we're gonna go to details, chapter 10. And in chapter 10,
Okay.
look at page 309. Here is not gonna be much. On page 309, right on the very bottom of the first column, the penetrations and clearance, it talks about the maximum amount of space should be provided. Starting on the third line, NRCA recommends minimum of 12 inches of clearance between pipes, 12 inches of clearance between pipes and curbs or walls, and a minimum of 24 inches of clearance between walls and curbs.
This is also in the green book, right? The 12, the 12, the
The Green Book is
24.
slightly different because the Green Book has the valleys, but it's pretty much the same. This is for flat
Yeah.
roof. Remember,
Yeah,
you're gonna see, actually, you'll see on 310, page 310, take a look at the details. And it shows you whether
Okay.
the 12 inches, and then 24 inches.
okay. Thank you.
Okay, then we're gonna have on 311, non-combustible substrate. On 311, torch applied and polymer modified flashing in non-combustible substrates. When using torch applied polymer modified bitumen membrane flashings over non-combustible substrates, NRCA recommends the use of non-combustible can strips. Then 2 more lines below that. NRCA suggests the use of non-combustible perlite, stone wool, or other similar non-combustible material for can strips.
In the first column,
No,
Second
second
column.
column,
Second column, middle.
non-combustible substrate.
On non-combustible substrates, 311 in the middle of the page, and second column. And let me see one thing. I just want to make sure. On the, I think this is it.
NRC recommends and then NRC suggests.
NRCA, right, NRCA recommends. Yeah, this is it, and this is the last one. See,
And
the other
NRC
half of the book-
suggests.
The other half of the book is details. All the different details. See, this is a good book to keep.
Oh, yeah.
reference. Show you how to put together, different details of different sections.
Perfecto.
And we're done. Now, we will be having, God willing, the workshop this coming Sunday in Doral, and it starts at 9 o'clock. And it's going to be live and online.
It's not Tamarack?
Come back.
The workshop is not on Tamarack?
I thought it was.
In Tamarack, it'll start at 9 o'clock.
It's in Tamarack, not Durham.
Tamarack, yeah, in Tamarack. I'm sorry, I said Doral. That's my bad. In Tamarack, it's in Tamarack, yes.
And it'll also be on Zoom.
And it will be on Zoom. It will be on
Excellent.
Zoom, and there will be a test. And we're gonna go over a test questions, all the questions. We're gonna go through a test, an 85 question test.
Great.
Gonna
we
be due on
didn't-
Sunday, right?
what the question come, what book it comes from, and how do we play with the questions to see where we go find it.
Oh, so
Until
we're not
when?
gonna take a test and try and see what we get on it and then go over the
No,
answers?
no, we're gonna go over questions and then look at a question and then, you know,
Okay,
have a comments on where to find it. And how to get there,
fantastic.
all
So
right?
Sunday be from what time, 9 until when?
4,
4, okay.
Yeah, normally it's
it's at
9 to
4.
4.
Yeah,
It's just
Yeah,
on Sunday,
that's-
right? This
yeah,
weekend?
4 answers, you know, it's a multiple choice. You have four choices to pick up to answer the question.
Is there any breaks in between?
Pardon?
Any breaks?
9 to
Okay.
4?
9 to 4.
Yeah,
Come on.
definitely.
That's like a half a day of work.
All right, guys.
Do I get the time
See
for my
you Sunday.
Thank you.
Thank you.
Thank you.
thanks,
Good
Mike?
Thank you
luck.
so
Good
much.
luck, Pedro. Good luck.
Yeah,
Pedro.
Pedro.
Good luck,
Thank you.
Pedro.
Pedro.
All right, I'll
Thank
be
you,
there
Pedro.
Sunday.
Thank you.
Let us know.
Pedro. Pedro.
Yes, sir.
Espérate.
Yes, sir.
Pedro.
Mucha
Yeah.
suerte.
Yes.
Pedro, can you send me your telephone number?
I can.
My number is 40. You got a pen?
Now I do. I didn't have one, but now I do.
404
404
414
414.
6242.
All right, 6242. Now in Spanish. What is that?
404
954
414
después de mañana.
Mariano. All right, no problem. I'll text you.
Y no me llames tarde para la cocina.
All right, I'll be there Sunday too, just to say hi to you guys.
All right, guys.
Bye.
All right.
Thank
Y'all
you.
have a
Bye.
wonderful
Bye,
night.
everybody.
Thank
Good
you.
night.
Thank you,
Good night,
everybody.
everyone.
Appreciate it.
Thank
Good
you.
night. Thank you.
Goodbye.
Thank you, Lena. Bye-bye.